Good evening, Prof. I'm demonstrating my big data project, which is real-time facial detection using HAL-like features. It's a slight modification of my initial proposal, but it's within the same range. So the research question that I've got is how to detect instances of faces in real time using various algorithms. So with big data, to address scalability, I want to actually ensure that if there's a video or images coming in, can I actually find faces in real time? Problem background: in computer vision, it's very difficult to find faces and images using real-time data. So problems such as localization and classification requires that we have models that are well trained to classify instantly. The proposed solution is obviously to use hub feature-based cascade classifiers. These classifiers are very useful because they're able to detect faces from images or videos. So if you've got multiple objects, you can easily determine faces in those images or videos. These classifiers are effective because they've got lots of trained data. So we've got lots of positive and negative images. So Intel provides this kind of classifiers. So OpenCV has built-in algorithms which are very useful for facial recognition, and I'm using those ones. So local binary patterns is the ones that I'm using intensely, and it's very simple. It uses the concept of texture matching. Other algorithms applicable in detecting faces are Fisher faces and Eigen faces. This is my solution pipeline. So we've got our half features, extraction, so we're detecting faces. We're saving those images, and then we train all image for classification. We apply the face recognition algorithm, and then we visualize our results. So our results basically, I've stored them in the text file, and then later on I use them to plot graphs. So we'll find that whenever a face is detected, we get something called the region of interest, and then that's just where the actual face has been captured. So those that region indicates a true positive rate. In cases where we are running our trained classifiers, false positive rates are detected because sometimes faces are not recognized. We'll demonstrate that more in the video. Confidence is also recorded. So a confidence of 0 means accuracy, and that's what we are trying to get to. Sample results: we've got two figures, one demonstrating the confidence levels on this side, and then the other one is more of a ROC curve for the positive and false positive rates. So these are some of the references for the data source. So now I'm demonstrating the actual project. So if I run my main file, let me just zoom in a bit. This is my interface, my GUI interface, and I've run my main application, main.py. So what happens here is the first step is obviously to load face detection using the cascade classifiers. Currently, this is my project structure. So when you go to training, you've got no images, so we haven't trained anything yet, and then obviously the results, there's nothing in yet. So the first thing that we want to do is get the half features. So we want to get the images. So we're loading this video in real time. So what it's detecting is, where do we actually find faces? Where do we find? So every time we find a face, let me just go back there. So every time we find a face, we find the region of interest, we note it down. Region of interest, we note it down. And what happens is, when we go to our training images, we find that we're writing those images to file. So this is happening in real time, because if you would observe now, can you see this? So here I'm trying to address the issue of scalability. So can you see? Pop. Let's wait. There, we're loading in real time. So what happens there basically is, every time we detect a face, we actually write that down. So there's another face, so it should write down. It's writing to file. So to open the source code for that and just explain that quickly, so this is actually the main file. So what I'm doing here is I'm creating a class that will deal with the entire GUI application. So it's just for the menu strip, menu file, having your have features, training, and invoking those methods. These are some of the methods which are invoked. So if you say python hard.py gets invoked there. So that's the whole idea. But with the training, with the have feature, basically this is a have feature class. So what happens here basically is we train our images. So every time we capture that region of interest, we want to write that down to file. Then we write positives. And then as we go down, these are the boundaries. So the boundaries, the whole idea with boundaries is that if we go within your face, we want to capture the exact location of where you are. And yeah, and then we're writing down true positives, and then we're writing those to files. We're getting coordinates of where exactly you are. So we're iterating through each feature. And then finding face is the actual using the coordinates to find the actual face, where the face is actually located. Then we use the image training that we created earlier to put the image on disk. Then here we calling our default frontal face. These are our trained cascade classifiers, and here we're calling our image, which is called train.mp4. So this is where we're loading our video in real time. So the next step obviously is to create. So this part is I think we are done for now using this part. So what we can do now is actually train our classifier. That's the whole idea basically, because we've got our region of interest, which represents the actual location, and it's used to train the actual recognizer. So when we go to training, before we train, currently we don't have any classification. So when we go to our project, okay, so when you go inside our project, we don't have our own classifier that we've created. Okay, we've got the eigenfaces, but we don't have the local binary histogram file. So we want to train that one specifically. So if we invoke our training method and we look down here, so what's happening here is that we're just waiting for the training to occur. Okay, so there's our training classification.yml file. So that's where all those images which have been trained have been stored to. So now what we need to do obviously is run our algorithm to detect in real time if we were able to train those images successfully. And now we're comparing. So we want to see that, okay, can we recognize those instances? So using this, so this is another, so can you see here what we're having is it's failing to detect faces in real time. So there's a face, there's a face, nice, there's a face. So it's a bit slow, So now we actually invoking our recognizer to use the classification file that we've created. It's a bit slow. So what it's doing in the meantime here is that it's writing the false negatives, false positives, I mean, and the confidence score. So it's noting it down every time it finds. Look at this. This is a bit more accurate. This is a bit more accurate. So these ones would have a very, very low confidence score, as you would see. And